Hi, everybody. Welcome. It is Monday night. It is time for Module 2, and we're going to get started with that tonight. So I'll give people a minute or so to join in. As usual, if you have questions, you can leave them in the chat or on Discord. And today we're going to just be looking at two parts of this couple weeks module. We're going to look at the at-home experiment, some details about what you should be doing with that. And then we'll get into the activities, the matter and atoms activity that you're going to be working on this week that'll contain the material for the first quiz, which is at the end of this module. All right, give people another minute or so to join in. So while we're waiting, all of your at-home experiments that I saw last week, I've gone through the ones that were turned in on time. If you talk to me and needed a little bit more time, then I'll look for those when they're ready. But the ones I saw, almost everybody, it looked fine, and go ahead and start your experiment. Make sure you read your comments that I left you. For some of you, for just a couple people, it was not an appropriate experiment because of safety or something like that. So if you got less than full credit on the proposal, make sure you read the reasons why. And if it's not clear whether I'm approving it or not, ask me, but it should be pretty clear. If it's not approved, you don't just lose those points. You just have to do it again, and then it'll be fine. So please resubmit, either change your experiment in the ways that I've suggested or find a new one that works better. So yeah. So as long as I've seen that and everything's okay with that, then you should be good for proceeding with your experiment. So let's take a look. So the first thing I want to look at is some of the details for that experiment. And I just picked a random one that I found online. How to make ice cream in a bag. Now, this is a fine one to do. But the reason that it needs to be changed a little bit for the class is because this is a recipe. This is not an experiment. All right. So this is in science and whatever. It says it's a delicious experiment. It definitely shows some interesting concepts, but it's not an experiment. It's a recipe. You follow the directions, you make the ice cream. That's it. That's done. That's not really the idea of what, or that's not the main idea of what we want to do these experiments for. If you think about the one that we did last week with the kit, it was like, here, do this thing, but then also there's this unknown that you have to match up, and we have to figure out like the different inks and answer some questions about the different inks. So the idea is that your proposed at-home experiments are similar to that. They require some thinking and some changing. So that's why that last question that we talked about last time, the what are you going to change, becomes so important, because that's really kind of your key to making a good experiment. So let's just, as an example, let's take a look at this one, how to make ice cream in a bag. So you follow the recipe, you make your ice cream base, you put it in the bag, you put in some salt, and you do what it says and open it up, and you've got ice cream. Just a tip, if you are actually going to do this, if you put it in the freezer after you make it, it will harden up even more. It'll be good ice cream. But there are some suggested changes here. You could use other types of salt instead of sodium chloride, but you couldn't substitute sugar for the salt because sugar doesn't dissolve well in cold water, and sugar doesn't dissolve into multiple particles. So like, the multiple particles are better at lowering the freezing point. So that's a potential change, is you could try doing it with something other than salt. It says you could use other types of salt. So what if you used it with like the ice melt stuff, not just pure salt, but the more expensive ice melt, the little white spheres, that's calcium chloride, and you could see, and so you could do like a side-by-side experiment. You try to keep everything else the same. The only thing you've changed is the type of salt, and see if that makes a difference in your observations of your ice cream. Is it, colder? You could check the temperature. Is it creamier? Is it more frozen? Whatever. So that would be a way where you change just one thing and then you look at the difference, keeping everything else the same. Other things you could do would be potentially to, kind of ruin your ice cream, which is fine because the idea here of the experiment is to figure something out. So you could like see what happens if you leave some of the cooking type ingredients out. What if you don't use, like, they have half cup milk and half cup cream? What if you just use milk? What happens? Um, what if you change the amount of ice that you're using? This says 1/2 to 3/4 cup sodium chloride. So you could look at some of the extremes of that. What if you don't use the salt? What happens if you don't use the salt? What happens if you use all the way up to that 3/4 of salt? So the idea of the scientific method is you're trying to control everything, isolating just one variable that you're changing. And so whatever you're doing for your experiment, regardless of how it's written up in the official directions that you find, the interesting thing is if you can then change it or just change one fairly small thing, keeping everything else constant, so that you can really like figure something out about that process. And so then you do the experiment, you write down all your notes, and maybe the thing that you change leads you to some other thinking. Like, oh, well, if this did this, then what happens if I use even more of that? Or if this really didn't work this way and it did work this way, so what is causing that, or what's in the middle? So that might make you think of some more experiments that you could try. You don't have to spend a ton of time on this, but keep in mind if we were in lab in on campus, we'd be spending 3 hours in there per lab, where we'd be working through some experiments. So if it takes some time, it takes some time. I don't want you to upload a 3 hour video to Blackboard. I don't even know if Blackboard can handle that. You can just kind of show some of your results or something that you did, and then some results, something like that. But if you want to keep experimenting and try to build it out a little bit, that's great. And then with our kit experiment and the future kit experiments as well, there are some questions at the end, like what happened, how do you show what happened, what part of the scientific method did you use, this sort of stuff that you answered last week. What you can do with your own experiment is think about how you would write this up. So like, what were your results? What are all the things that you were able to figure out about this process because of the things that you changed and the experimenting that you did? So if your procedure is very much just like a recipe, or if what you find is just follow the steps and do a recipe, change things so that it really becomes an experiment and you're really kind of playing with it and seeing, what does this do and what does this do and what happens if I do this and what happens if I do that, and just make sure to keep really good notes in your notebook so you can keep track of all that and all those changes. All right, so I think that's all I have to say about the experiment. So when you do that, the things that are due from the experiment are some sort of video of part of the experiment that you did. And that's posted in a discussion board. And the reason for that is so that way everybody can see, and maybe get some ideas for future experiments. If they see you do something and they think like, oh, like you changed, all right, so maybe you did this ice cream thing and you looked at sodium chloride versus calcium chloride as like different salts. So somebody else might say that and say, oh, you know what? I've got some potassium chloride in my cupboard, or I've got some sodium bicarbonate or whatever. Maybe I'm going to do the experiment with that instead. And so you write up the proposal with that, and that gives you some ideas moving forward, because we're going to do 4 of these over the course of the semester. And then the notebook pages you'll just submit like the other stuff as a PDF so that I can look through and grade them as your lab. All right, I'll pause here for any questions. Okay. Moving on. Let's take a look at these activities that we're starting this week. Now, we're going to do a few of these throughout the semester. I would say it doesn't really matter, but I'm going to start with this one today, the types of matter, and then we'll probably look at the atoms one on Friday. So this is kind of this weird thing, and it looks like just your standard worksheet. Like you fill in the blanks. It's not fancy. It's like a black and white scan from a book. Doesn't look like anything interesting, but it's actually a really innovative way of learning this material that works really well if you do it correctly. So where this thing comes from, or where these things come from, is this idea that you learn best if you create or construct the knowledge yourself. So instead of like reading a fact and then trying to remember it, you look at data and you try to like come up with the fact yourself based on what you see. All right. And that's also kind of mirroring the scientific process. You look for observations and then you come up with the rule or the law or whatever that explains those observations or that describes those observations. So with each of these, what they basically do is they give you some information with no context. So you'll notice at the beginning of this sheet, there's no instructions. There's no like context or anything. There's just model 1, examples of various types of matter at room temperature. And then there's various types of matter: aluminum, hydrogen, water, table salt, salt water, coffee, black coffee, muddy water. And then they have a bunch of data associated with them. So there's a classification, there's a state, and there's a formula. And then there's a bunch of words and stuff under there. And the assumption is not that you know what those things are. The assumption is actually that you do not know what those things are. And if you do know what they are, I would encourage you to suspend your knowledge actually while you work through this activity, because there may be a chance that you have a misconception about some of those. And this will be a good way to think about that and actually get that corrected. So pretend you don't know anything about this stuff and you only know what's given in the table here. So you know now that aluminum is classified as an element, its state is solid, and its formula is Al parentheses S. All right, and it doesn't give you any context. You don't know what that means necessarily. You just have that data. So the reason I go through that, then when you get down to the questions, the point of the questions is that you should answer them only using the information from the model or from the worksheet itself. So when you see these critical thinking questions, you're only using that information. All right. So you're not looking stuff up. You're not pulling it out of your head from a previous class. It doesn't matter if you've learned this stuff before or not. The idea is, can you take this table of random sort of data and from that develop rules that make sense and that become definitions? So let's do the first ones together so you can kind of see how this works. So it says, consider model 1. How does the formula of an element differ from that of a compound? All right, so that is not saying go on the internet and look up the difference between an element and a compound. It's saying using just the data in this table and just looking at those things, how does the formula of an element differ from that of a compound? So you might look at the formulas here, and you'll notice that these top two are categorized as elements, and the next two are categorized as compounds. All right, and that's it. So then let's just look at these formulas and find something that's different. So how might they be different? Well, I can look at these and I might say, all right, well, I can see there's only one type of atom in the top ones, and there's two types of atoms in the second ones, right? That's a difference. So I would write down over here, elements have, I'm going to do it because it makes everything shake if I write a bunch, but elements have one type of symbol and compounds have two types of symbol. Now, is that like the overall rule for distinguishing elements from compounds? No, but that's what you found from looking at just this data. So then the second question is very similar. How can you distinguish elements from compounds based on their chemical formulas? Notice the first one said, consider model 1 specifically, how does the formula of an element differ from that of a compound? And then 2 is saying, how can you use that information in general when you encounter new materials to figure out if they're elements or compounds? So the first question has a very specific answer based on the table. The second one is that broader rule. And by constructing it that way from the data, rather than just looking up the definition, you'll actually learn it better and it'll stick with you. So, so that's why these should be done in that way, where you look at the data and then you write down your answers based on what you see there. So then we go down to question number 3. How does a pure substance, element or compound, differ from a mixture? Describe. So now I'm going to look up here again, and this time I'm going to compare the pure substances, the elements and compounds, from mixtures. And so I can see here that in my elements and compounds, I have multiple, I said what I said about the formulas before, but I have only one type of overall formula. Whereas in the mixtures, it seems like there's always this and. So I'm looking at this and this and other stuff, this and many others. So something important about those ands, that there's different types of things in there. And of course, you could probably guess that based on your own knowledge of, the world, that the difference between a pure compound and a mixture is that a pure substance in a mixture is that a pure substance is only one kind of thing and a mixture is multiple kinds of things mixed together. And then the fourth question says, hypothesize on the meanings of the labels S, L, G, and AQ on the formula. So this one isn't actually even asking you to come up with the right answer. It's just saying, what do you think those things might mean? And then actually in the next paragraph, it tells you what those things mean. So the reason for doing this, again, is not so that every question has exactly the right answer all the time. It's so you are actually engaging with the material and thinking through it. So as you fill this out, please kind of have that mindset. I'm not going to go through these worksheets and grade every question on what you got right or wrong. I'm going to look at a couple things and basically see if you did a good try with it. But what you do need to know, what you do need to be able to do is ultimately perform this and be able to classify matter on a quiz. So if you go through this the way that I'm suggesting and the way that these activities are built, you'll have a much better chance of actually retaining that information and learning the stuff for the quiz. Now, in a later class on, I guess this would probably be next week, I'll go through the answers so that, and answer your questions. So if there's ones you weren't sure of, you have the right answers before the quiz. But the idea is that if you work through it in this particular way, you will learn the stuff better than if you just look up the answers and write them down. Okay. So then if we go down here to this classification of matter, this is actually where it will explain all that stuff for you. So it'll talk about what's the difference between substances and mixtures, elements and compounds. So, you could theoretically just look up the answers on the next page of the worksheet and fill them in up here. But it's not built that way. And as I said again, it's not built that way for a reason. The point of this is not for you to get the right answers on the worksheet. The point is so you learn the stuff so you get the right answers on the quiz and you ultimately know the stuff. So if you go through in order and then check your answers with the informational paragraphs later, you'll have a much better chance of really understanding the stuff. All right. For the next section here, if we look at 7 or 8, you're going to need a periodic table of the elements. So you can find one of those various places online. You can just search for a periodic table picture, and anything should pretty much work there. And then this part, so after the critical thinking questions, which are this idea that like you look at the model and then you answer the questions based on the data, then you have exercises, which are more like traditional answer the questions. But if you've done a good job of constructing those rules and it made sense, then the exercises should be something that you can do with your knowledge now. So in this case, you're seeing some models of some chemical compounds made of some different types of elements, and it's asking you to write formulas. So after you've understood what a formula is and kind of thought about that a little bit, then you can do stuff like this. All right, and then it's just identifying some elements and in some compounds, which you can use the periodic table for as well. You won't ever have to memorize names of elements in this class. You will always have access to a periodic table to use when you're doing your work. All right, and then moving on to number 3, all of this stuff is important, but I'm just going to say this one is the main thing. I don't know, my pen looks a little weird today for some reason. Running in the background. Stars there to make it look nice. This is ultimately what we want to be able to do. Can you classify matter as an element or a compound, a homogeneous mixture, or a heterogeneous mixture? So as you work your way through this material and through this activity, keep in mind that the point at the end, or the goal here, is so that when you see something like apple juice, you can put it in a category. And I'm going to say you should be able to explain why you picked what you picked. You don't have to do it on paper for this activity, but just in your head, when you make a decision about how you're going to classify the matter here, why? Where did that come from? Now, some of these you may have to look up. So like not look up whether it's an element, compound, homogeneous, or heterogeneous mixture, but look up actually what it is. So you may not know what 14 karat gold or 24 karat gold is. Go ahead and look that up. You may not know what concrete is made out of. Go ahead and look it up. But then make your distinction as to whether or not it's an element, compound, homogeneous, or heterogeneous mixture. Again, I'm not going to grade you on whether you get this correct. As we'll talk about next week, some of these are pretty ambiguous, and they could actually have multiple correct answers. The point ultimately is, can you classify them, and can you explain your classification? And then can you do it for the quiz? So it's not worth it to just look up the answers and write them down here, because that doesn't really teach you anything. The idea is, can you classify them? And if you're having trouble with that, let me know, or ask your classmates on Discord, and we can have a discussion about, maybe people have some different techniques or some different good ideas on how to do that. We'll go through it on next week, but since this is the first day of the module, I want to give you a chance to work through it this week before I just go through it, so that you can try it on your own. All right, and then finally, the last couple of questions. This activity comes from a textbook, so there's like some other stuff that you're supposed to do, but we're not going to do that. So you don't have to memorize names and symbols of elements, and you don't have to read assigned pages in the text, at least for this part. So that's the matter activity. Now, if you want to spread things out, again, we've got a 2-week module here. So I think it's a good idea to think about your own schedule, especially if you're working or if you have family commitments, and think about when you can actually do this work. So maybe, Wednesday night's scheduled for your at-home experiment, and then Thursday morning you're going to do your article report, and then Saturday works for this activity, and then maybe Monday for the atoms activity, and then you're going to study a little and do the quiz on Thursday. I don't know. But, kind of plan it out a little bit so that you have time to do the stuff that you want to do, and you're not just trying to get it all in next Friday right before it's due, because it's a substantial amount of stuff. If you do want to work ahead, The second activity, the atoms activity, is very similar to the matter activity. You can see with the font and stuff, it comes from the same place. And the idea is also the same. So there's this first model about atomic structure and the structure of some different atomic particles. And then the first questions are these critical thinking questions, which say, just look at this diagram, and from that diagram, answer the questions. And this one in particular, I've found in the past, especially when we would teach in person, and I could actually see like everything people were talking about. We would do this in groups usually, and people would discuss it. A lot of you, whether you know it or not, have some misconceptions about atomic structure. Stuff you learned wrong in the past, or maybe stuff you learned right, but then like forgot or got twisted around in your brain or something. So don't necessarily trust what you think you know about atomic structure, about protons, neutrons, and electrons, and isotopes, and all this stuff. See if you can kind of block that out a little bit and start from zero with this activity, and see what you come up with. So in this model, just to explain it, I'm going to go through this in more detail on Friday, but it's got these different color, or different amounts of shading in these little balls, and those correspond to the subatomic particles, protons, neutrons, and electrons. And from those data, as well as some of this other stuff, these unusual, or maybe not unusual, maybe unusual to you, chemical formulae that have these little numbers in the corner and have these plus and minus signs in the corner. There's some different names. There's a lot going on here. There's carbon, carbon, carbon ion. There's different types of symbols for them. They talk about isotopes. They talk about nucleus. So if you go through this, the idea is that you can figure out what all that stuff means just by looking at similarities and differences. So if you look at what all 3 carbon atoms and ions have in common, and then what all 4 hydrogen atoms and ions have in common, and then what all magnesium atoms and ions have in common, maybe you can figure something out about what's important, what determines the name of an element, what determines the identity of an element. So rather than look those things up, and these questions should be, at the beginning ones generally are like extremely simple. What do all 3 carbon atoms and ions have in common? So you look at the particles and you just count stuff up, and you might be able to see it right now. But that's the idea, is you kind of come in here with nothing, and you look at the pictures, you look at the models, and you try to construct the meaning from that. You try to answer the questions from what you see rather than external sources. So there's no textbooks, there's no other stuff, reference material. Can you figure this stuff out just from what you see here? All right, so we'll get into this in more detail on Friday, and talk a little more about atomic structure. If you have some time this week and you can get some of the stuff turned in a little early, that will certainly make things easier and give you a little more time for the other stuff. So yeah, everything's officially due next Friday, but it's always good to space things out, turn them in as you can. Are there any questions for those of you here live? I'll just pause for a little bit and let me know if you have anything that you want to know before I sign off for the night. I'll check Discord as well. As we're waiting again, just the goal for this module is to think about, to understand atoms and molecules, classifying matter, distinguish chemical and physical changes. Those are the outcomes that you can expect to be quizzed on at the end of the week. The things you should do: perform your at-home experiment, and then there will be a practice quiz next week that will kind of be like the regular quiz, but with different questions, so that you can get a sense of what that's going to be like before you do it for real. And then the assignments that are due, so you got to have that activity completed, and either you can print it, write it, and scan it and put it in, or you can just fill it out on a device and upload that. You got another article report just like last week. and then your at-home experiment stuff and the quiz. That's it. All right. I am not seeing anything coming up in the chat at the moment, so I'm gonna say good night. Let me know if you have more questions. We'll be back here Friday morning. We'll talk more about the Atoms activity, and if there's any other questions that have come up this week, we'll look at that. And yeah, I'll stay on for another minute or so if there's any more questions. Okay. Well, good night, everybody, and I'll see you Friday.